What is up? So in this video, I wanted to talk about a double exponential that's happening right now. So a double exponential, you have like exponentially growing, right? So the rate of growth continues to accelerate. And you have it in two arenas that are combined to one thing, Bittensor. If we take a look at this here, we have PubMed's crypto search, which is a aggregator or database of research papers. When you look at the timeline here, this shows us the number of research papers that are being released with crypto in them. So the amount of interest in crypto and cryptography is growing exponentially. So we have the exponential of crypto expanding, and then we have artificial intelligence, AI. And this is a much, much smoother curve here, but they're both growing very, very quickly. They're growing exponentially over time. And this is going to continue, right? AI is going to take over or influence everything moving forward. And in the next 10 years, every single person is going to be in crypto. And that is what we're going to talk about in this video. We're going to get into Bittensor, what it is. They actually have two different consensus mechanisms. So we're going to relate that to Bitcoin and Ethereum, explain those two different networks, consensus. Then we're going to get into the different parts of each consensus mechanism and how they work and the different players involved. And we're going to get into the inflation of the system. So with that being said, if this is your first time here, what's good? My name is Sam, and if you are returning, it is good to freaking see you. If you're listening to this, how is the audio? Okay, it's on. The microphone's on. Okay, let's get into this. I put together this awesome graph here. I'm going to pull up to illustrate this more simply. So you have proof of work, right? That's Bitcoin. Proof of energy, effectively, where when you go through, let me hide this over here. If you're getting distracted because I have myself up on the screen over here. So proof of work. Miners will go through and solve a cryptographic problem to get the block rewards, which is the Bitcoin that's mined, right? So if you look down here, what the miners are effectively using energy to secure the network. This, let's see here. Okay, so this is helpful in many ways. So it's the most secure network in the world. It's also the largest supercomputer in terms of compute power in the planet. It dwarfs the size of any other supercomputer in the planet. It's got computation. The miners solve computational puzzles to solve. They only get rewarded when, if they're in like a mining pool, or they're a giant miner themselves. So that's how it's split up. I want to highlight some of these things so that we can contrast this to Bitcoin, which is similar to the subnets. Now, let me zoom out here. Ethereum switched to proof of stake a couple of years ago. And it's basically just proof of money. It's way more efficient from an energy usage standpoint, but they're different. There's big differences. In my opinion, proof of stake is going to create centralization through capital. So capital likes to centralize. So when you have something like proof of stake or proof of money, money likes to be efficient. So money is going to go to the most efficient spot, which means it's going to centralize as time goes on. But that's a topic for another video. But basically, the validators validate transactions in the system, where proof of work, the miners solve the cryptographic problem. They're both going through and securing the network. Now, these tie into Bittensor. Bittensor takes proof of work and proof of stake into its network. It has two different consensus mechanisms that we talked about. So let me just touch on this over here. We have the local consensus and a global consensus. So the local consensus is made up of like the subnets and the validators. So each part, the inside of the local consensus, you have these three people or parties, I guess you can describe them as, where subnets are effectively the drivers of the ship. They're going to point the AI in one direction. Like, what problem do they want to solve with AI? That's going to be the subnet. They're going to pick the direction of where they want to go. This subnets also create the consensus for the network, which we're going to get into more of those details in a moment. Validators will validate miners' outputs and rank them, stack rank them within each subnet. And then miners will contribute their AI models, their data, their hardware, their all of that. They'll contribute to it, as well as the output from their models back to the validators here. And the subnets are basically setting the parameters which these other two players will play in. The miners and validators are basically going to play in the sandbox that is the subnet. Validators get rewards from the staked, right? So this is where you come back over to here, right? You have the proof of money and proof of energy, right? So the miners are going to be working like proof of work here, and the validators are basically working as proof of money here. And then all of each one of these is kind of, I think when I'm talking about this, I think of like the US government, right? Like we have different branches of government. Each one of those is supposed to work to offset the other one, so to speak. And that's kind of how you can think about this. Now, that's the local consensus. At each subnet, they're going to have a consensus level of like multiple miners, multiple validators that go into that local consensus. You can be a miner on like multiple subnets or all subnets, or you can be a validator on one subnet or all subnets. Now, the person who wants to optimize for money, right, has to take into consideration, say from a miner standpoint, if I want to make the most money and I'm a miner, then I could mine across all the subnets. Each one of them is going to get ranked differently, which means my emissions or the inflation, the block rewards, so to speak, are going to be different for each individual subnet because each subnet has its own ranking. So if I'm a miner and I want to get the most amount of rewards, right, then on the one hand, I'll be like, okay, cool. I want to mine for as many subnets as I can, right? Now, on the other hand, to like offset this, right, or contrast it, each subnet has different requirements for the type of data, how it's done, the different hardware, how it's ranking everything, its own consensus, like what it's looking for that the validators are going to confirm. So to mine across multiple different subnets is challenging, right? So I can be the top player in like a small pond, or I can be the top player across multiple. But like to be a top player across multiple different subnets requires a much greater level of expertise, hardware, data, etc., to be able to perform at a high level across multiple subnets, because each subnet is going to be different. Now, the same thing goes for validators. A validator who is going to stack rank the miners within each subnet has to consider what sandbox is playing in, i.e. the subnet, and then it can be a validator across all of them, because then that's where you're going to make the most money, presumably, because then you can get a little bit of money from each individual subnet. However, the data needed, the hardware and expertise needed to validate across all the subnets is slightly different. So it also is more complex and harder to do. I would say, without like the technical background, it's probably easier for validators to validate across multiple subnets than it is for miners to mine across multiple subnets. Could be wrong, but it seems like that would be the case. And then the subnet owners, they can, you can have multiple subnets if you wanted to. There is a cost to that, which we can cover in a different video. So that's like the local consensus. Now, the global consensus here, because you have a bunch of different subnets, each individual subnet has a consensus associated with it. All of the data from the local subnets flows over to the global consensus. This is where subnet 0, or the root subnet, pulls all the data from all the different subnets. So right now there's like 60 something subnets in there. So it pulls the ranking from the validators on all these things, the inputs, etc., from the miners to validate that. So again, you have the same thing where you have proof of work, right? Where is it? Proof of work and proof of stake coming into subnet 0, which does this. Now this one's really easy to understand in the sense that miners will basically work as proof of work to solve a cryptographic problem related to, say, transactions, staking, or delegating on the network. But then they'll also like pull in the data for all the individual subnets. And then that's where you get those two pieces, right? Because they're pulling in all the local data from all the local consensus, as well as the global consensus across the entire chain. And what comes out of this global consensus is inflation, because the consensus is going to basically dictate how players in the game get rewarded or, earn money. And that's how most of it, like, if you look at people's behavior, that's going to be the biggest piece for the vast majority of people, is they just want to make freaking money. They want to make a lot of money. And so that's why they're contributing there, because of that. Plus you have, a fixed inflation rate. So the rate of TAO that is emitted, so emitted is basically just the inflation in the system, is around 7,200 per day. So it's like 1 every 12 seconds. So at a price of like, say, $500, that's $500 every 12 seconds, right? That's, $3,000 per minute or something like that that's coming out. So $3,000 per minute. How do you split that up between the players? Well, the consensus mechanism that's attributed to subnet 0 is going to split that between the different subnets based upon the input from the validators at each local subnet. Right, so that's all pulled over here with the miners, and then there's the validators underneath subnet 0 that are going through and creating this consensus based upon all the data and the consensus from the other validators across the network. So in this case here, we have, let's just say there's 4 subnets. You have inflation that comes down, and they're like between the 4 subnets where it's split between these. And these are going to be based upon, let me write this down in here somewhere, where miners are going to be rewarded based upon their performance in the network. So here it is. Validators their rewards are basically going to be from the amount of money they have staked, the uptime / performance, and their accuracy of validator relative to other players in the network, right? So like there's not like slashing or penalties like there is with ETH for being a validator, but you're penalized in the sense that you get lower rewards the less accurate you are, the lower your uptime is, and the less cash you have delegated to you, where miners are going to basically contribute the data to the validators. The validators are going to query the miner to ask them questions effectively, and they're going to rank those. So the miners are contributing their hardware, their expertise, their models, their data, and this is all validated. So if it's you, me, and 10 other people all playing this game, and validators are going to ask us questions, then we're going to get stack ranked 1 through 10 on this, right? And there's 4 subnets in this case here. But obviously, there's way more than that, but in this case, it's split, say 15, 40, 10, and 35. Now, within each one of these, the distribution of inflation is going to be 18% to the owner of the subnet, and then the remainder is going to be split between 41% to the validator and 41% to the miner. So if you look at this and you figure over, let's say that this ranking here stayed the same for like 100 blocks. So that's going to be 100 TAO, right? So 100 TAO, if these all stayed the same, means that on subnet 1, the owner of the subnet would get 2.7 TAO, roughly, right? Which is 15% of 100, and then 18% of 15, right? Because how the math works out, it's 2.7 TAO, right? At $500, right? You got $2,600, $2,700 of rewards over 100 blocks, right? At 100 blocks, if you're getting, 5.5 blocks per minute, that's 20 minutes worth of work, right? In terms of rewards. Now, in terms of cost, I don't know what the cost goes into being a subnet, right? And then the validators are getting 41%, and miners are getting 41%. So these this is like $3,000, a little bit over $3,000 for a validator, $3,000 for a miner at TAO at $500. So the higher the price of TAO, then if the rewards are not split in some period of time, then they're going to make more money throughout this. So I basically put this together so that I could build better understanding of this, because I am extremely bullish on TAO, given that is bringing together 2 exponentials, right? As we talked about at the beginning, and then we're going to wrap things up here. You have AI, which is growing like every single week, basically. I started with ChatGPT a couple of days after it came out, and I've been using it every single day since, more than Google. And then you have crypto, which I've been in for several years. And these 2 things are growing exponentially. And this protocol, Bittensor, brings those 2 things together. I think that there's, if you look at the history of like what's happening with TAO, I think that they have the potential to grow into the top 5 coins by market cap within the next 5 years for sure. I feel like there is some potential issues that need to be solved, but I believe they will. When you put together a lot of really smart, intelligent people, then that are all working together and incentivized to work together, inevitably they're going to come up with something really cool at some point, right? So I believe that over the next 5 years, this coin is going to be in the top 5 in terms of market cap, and kind of be like the Intel, say, inside of computers, where maybe that's I think that's an HP. Yeah, that's an HP computer, where people know the HP, but they don't necessarily know the Intel. I think that is how this is going to play out, where they're going to be using some type of AI piece of things, where part of the back end is actually happening on Bittensor. Also, I wouldn't be surprised if like the centralized players start to take portions of like the stack that makes up AI and utilize Bittensor for those pieces. So say like OpenAI, they need inference or data or processing power or something, right? Where they're going to actually, I wouldn't be surprised if in the next 24 months or less, this is actually getting portion of what they're doing is actually coming from the Bittensor network. Now, I think one of the potential problems with Bittensor is the issue, or like when you get great, absolutely amazing people together, and if they're not getting rewarded properly and incentivized properly, then the best people are going to leave. Like, that's why I don't work for somebody else and I do my own thing, because I done the thing working for somebody else and they don't have the proper incentives or things in place, right? So when this is kind of how the network's set up, I think dynamic TAO should help with this, and I'll do a separate video on dynamic TAO. But I think there needs to be incentives to keep the top players on the network so that they're contributing to the network, and tie them in even like more than they're already tied into the network, because otherwise you're going to have talent leaving, right? Like you probably are aware of the talent war, so to speak. Why is it so blurry? Okay. You're probably aware of like the talent kind of war between the top players like Google or Tesla or Amazon, where they're paying giant sums of money for AI engineers and ML engineers to come work for them. So the reward here has to be more sticky, and it also has to be larger, I believe, than how it currently is, which I do also believe that they'll get this figured out over the next period of time, and we will see when dynamic TAO launches how things play out. But if you like this video, share it with somebody else. Appreciate you, and I'll see you in the next one.